Today's video is about writing direct variation equations. So the objective is to solve for the constant of variation and then write a direct variation equation based on that information. We talked yesterday about direct variation, and the equation that represents that is y equals kx, or y is your output or dependent variable, and x is your input or independent variable. Okay, and that leaves k, which stands for constant of variation. And constant of variation is the number that relates two variables that are directly proportional. And the equation for just finding k would be y over x. Alright. So if we look at steps to solve these types of problems, first you're going to identify the independent and dependent variables, which is what we did in class today. So once you identify those two variables, you're going to solve for k, meaning you need to isolate the k, get it all by itself. And once you understand what k is, once you've isolated it, you can substitute that back into the direct variation equation of y equals k times x. So let's do a couple examples and see what that looks like, and then have you try for you. So Ella goes to Dillard's to buy jeans. She bought two pairs for $100. The total cost varies directly to the pairs of jeans she bought. And so first I need to determine what my independent and dependent variables are. Alright, so I'm looking at this, and total cost varies directly to the pairs of jeans bought. That sentence should steer you in a direction of understanding which one is independent and dependent. If the total cost varies directly to the pairs of jeans, that means that the total cost is dependent on the number of jeans that she buys. So my x is going to be pairs of jeans bought, and then my dependent variable, the y, is going to be total cost. Okay, and then k represents the constant of variation, which is what we don't know. Okay, so now that I've labeled these, I'm going to put the quantities, the actual numbers, into the equation of y equals kx. Okay, so since y represents the total cost in this situation was $100. The k, which I don't know yet, so I'm solving for k, so k is going to stay as a variable, and then it's being multiplied by x, which represents the pairs of jeans bought. She bought two pairs, so x will be 2. Okay, now I have an equation that I can solve. I need to isolate the k. I want to get the k all by itself. So k is being multiplied by 2, which means I need to divide both sides by 2 to cancel out and isolate k. So those will go away, leaving me with k equals 50. If k equals 50, I'm going to put that back into the original direct variation equation without any other numbers except k. So I would write y equals 50x. So this equation would represent this situation, and then moving forward you would be able to determine what a y is based on any x that you're given. So if Ella was given, or if she bought 1,000 pairs of jeans, you will be able to figure out how much that costs quickly using this equation. Example 2. Each calculator requires 4 batteries. The total number, or the number of batteries, varies directly to the number of calculators. So if I'm thinking about this scenario, I would say that the independent variable is going to be the number of calculators. And then the dependent variable would be total number of batteries. Right? Because the total number of batteries you would need depends on how many calculators you have. If you get more calculators, you're going to need more batteries, not the other way around. Right? And K still means constant of proportion or constant of variation. Okay. So I'm going to set up this equation based on the information I've already had. So it should be y equals kx. If y is the total number of batteries, in this situation, in this problem, it's 4 batteries equals k, which I'm going to solve for, and x represents the number of calculators. It's 4 batteries per 1 calculator. Okay, and then from here, I would want to isolate my k, get it all alone, so I need to divide by 1 so that they cancel out. Those cancel out, leaving you with k equals 4 divided by 1, which is 4. So if k equals 4, I'm going to put that back into my original direct variation equation. So it'll be y equals 4x. And that's all you do. I have one you try, and we will discuss tomorrow.